It was born from failure, a desperate response to Boeing's Dreamliner. Airbus had been caught flat-footed, watching airlines flock to Seattle for the future of aviation, the 787. The A350 wasn't supposed to be revolutionary, it was supposed to be enough. But something happened along the way. The A350 didn't just catch up, it changed the game entirely. Today, 675 of these aircraft have been delivered. They fly for 48 airlines across 6 continents. This twin-engine widebody didn't just save Airbus's face in the long-haul market, it became the new standard for how we cross oceans. This is the story of redemption written in carbon fiber. From the ashes of a failed A330 derivative to a complete reinvention of what long-haul aircraft could be, this is how Airbus built the jet that changed everything. Turn the clock back to the early 2000s, Airbus was riding high. The A330 had become the workhorse of long-haul routes, reliable and profitable. The less successful 4-engine A340 appealed to airlines that valued redundancy and ultra-long-range capability. And then there was the A380, the grand statement, the super jumbo that would cement European dominance in the wide-body market. Size mattered. 4 engines meant safety and prestige. Airbus believed the future belonged to hub-and-spoke networks, massive aircraft connecting mega-cities. Then, Boeing made its move. In 2003, Boeing launched the 787, now known as the 787. It wasn't the biggest aircraft, it wasn't even trying to be. Instead, Boeing promised something airlines had been craving: efficiency at scale. The 787 would use composite materials for its structure, cutting weight dramatically. Advanced aerodynamics and new generation engines would slash fuel burn by up to 20% compared to aircraft it replaced. More importantly, it was a twin. It could fly long and thin routes profitably, connecting cities directly without needing massive passenger volumes. The hub-and-spoke model was about to face serious competition from point-to-point flying. Airbus underestimated it completely. Leadership in Toulouse assumed airlines wouldn't abandon the comfort of 4 engines on long overwater routes. They believed passengers wanted space, not efficiency. The market, they thought, would stick with what it knew. They were wrong. By the mid-2000s, orders for the 787 were stacking up. Airlines were placing massive commitments. Meanwhile, A340 orders dried up. The A330, while still selling, suddenly looked dated next to Boeing's composite wonder. Airbus faced a crisis. Its entire long-haul strategy was built around aircraft that were rapidly becoming obsolete. The A380 was too big and too late. The A340 was too thirsty, and the A330, while decent, couldn't match what Boeing was promising with the 787. Boeing had redefined the future. Airbus needed an answer, and fast. Airbus's first solution was the most obvious one: take what works and make it better. In 2004, they announced the A350, not the aircraft we know today, but something else entirely. The original A350 was essentially a modified A330, same fuselage cross-section, same basic structure, new engines, some composite panels, updated systems. Think of it as the A330 with a fresh coat of paint and a few modern touches, like an A330neo. It was incremental, safe, low risk. Airlines hated it. Carriers looked at the proposal and effectively told Airbus to go back and try again. The original A350 design kept the A330's cockpit windows, those 6 panels in a conventional layout that had been standard since the 1990s. It looked old because it was old. By 2005, it became painfully clear that this was not going to work. Airbus was offering yesterday's solution to tomorrow's problem. Orders were minimal, enthusiasm was non-existent, and Boeing kept racking up 787 commitments. So, Airbus made the decision that would define the company for the next 2 decades. They scrapped it, all of it. In December 2006, Airbus's board of directors approved the industrial launch of a completely redesigned A350, the A350 XWB, extra wide body. This wasn't going to be a warmed-over A330. This was a clean sheet design, a ground-up rethinking of what long-haul aircraft should be. The goal was simple but audacious: match the 787's efficiency and take on Boeing's 777 at the same time. Build one aircraft family that could challenge Boeing across the entire long-haul spectrum. The pressure was immense. Development costs could exceed tens of billions of dollars. The A380 program had already stretched Airbus financially and operationally. A failed A350 would be catastrophic for the company. But Airbus didn't just redesign a jet, they reinvented their entire philosophy. Let's talk about a nose. Yes, a nose. Because sometimes the smallest details tell the biggest stories. When Airbus first revealed the A350 XWB design in 2006, it kept elements from that original A330-derived concept. The nose section featured the same 6-panel cockpit glazing used on the A330 and A340. Functional, sure, but visually, it looked conservative, conventional, like Airbus was still playing it safe. Everyone noticed it. The criticism wasn't loud, but it was consistent. The A350 looked too much like everything Airbus had built before. Where was the revolution? Where was the bold statement that this was truly next generation? Airbus listened. In 2008, they went back to the drawing board on the forward fuselage. The result was a completely redesigned nose section, featuring a sleeker, more aerodynamic profile with a distinctive drop. The cockpit glazing changed from 6 panels to 4, creating cleaner lines and better visibility for pilots. But the most striking change was aesthetic: a black mask around the cockpit windows that extended into a dramatic visor shape. It was instantly recognizable, aggressive, modern. This wasn't your father's Airbus. The redesign also brought technical benefits. The new nose structure was lighter, thanks to more extensive use of carbon fiber composites. The aerodynamics improved, contributing to lower drag. Pilots got better sightlines during approach and landing. But before the engineering, that black mask became a symbol. Virgin Atlantic called it a Zorro mask. It represented the moment Airbus stopped looking backwards and started leading. That nose design would later appear on the A330neo, the A220, after Airbus acquired the program from Bombardier, and eventually the A321XLR. It became the face of modern Airbus. The A350's nose wasn't just a design tweak, it was a statement, the moment Airbus shed its old identity and started leading again. Strip away the marketing, the liveries, the airline brands, and what you're left with is this: an aircraft that represents one of the most comprehensive engineering advancements in commercial aviation history. The A350 isn't revolutionary because of one breakthrough, it's revolutionary because of everything, all at once. Let's start with the structure. The airframe is up to 54% composites by weight, specifically carbon fiber reinforced plastic, or CFRP. The wings, fuselage panels, tail surfaces, all built from layers of carbon fiber. This wasn't just about saving weight, though that was critical. Composites don't corrode, they resist fatigue better than metal, and they allow engineers to create complex shapes that would be impossible with aluminium. The fuselage is a one-piece carbon fiber barrel, no riveted panels, no stress points where metal sheets meet, just a smooth, continuous structure that's stronger and lighter than anything that came before. Those wings are engineering poetry. They are massive, giving the A350-900 a wingspan of 64.75 meters, among the largest single composite parts ever built for commercial aviation. But size isn't what makes them special. These wings flex. Visibly, you can watch them bend upward during flight, adapting to aerodynamic loads. That flexibility isn't a weakness, it's a design feature. The wings use variable camber, adjusting their shape dynamically to optimize lift and reduce drag throughout the flight. At the wingtips, you'll find curved winglets called sharklets. They reduce vortex drag, saving fuel and extending range. Every surface, every curve has been sculpted in wind tunnels and computational fluid dynamics programs to squeeze out every possible efficiency gain. Now, the cabin. Airbus made the fuselage wider, hence the XWB designation. The internal width is 5.61 meters, creating enough space for more comfortable seating configurations. 9 abreast economy feels less cramped than on some competitors. Business class gets genuine space for lie-flat beds without sacrificing aisle width. But comfort isn't just about space. The A350 cabin pressurizes to a lower altitude equivalent than older aircraft, around 6,000 feet compared to 8,000 feet on previous generation jets. The humidity is kept higher, the air is quieter thanks to better insulation and the composite structure, absorbing vibration differently than metal. Passengers often say they feel less fatigued after long flights on the A350. That's not marketing, it's physics. The cockpit represents the next evolution of Airbus's fly-by-wire philosophy. Pilots familiar with the A320 or A330 can transition to the A350 quickly because the fundamental logic is the same. But the A350 adds touchscreen displays, enhanced heads-up displays, and better integration with data link communications. That consistency across the Airbus family reduces training costs for airlines and creates a pool of pilots who can move between aircraft types without months of requalification. Then there are the engines. The Rolls-Royce Trent XWB is one of the most efficient large turbofan engines, developed specifically for the A350. These engines use advanced materials, including ceramic matrix composites in the hottest sections. The fan diameter is almost 3 meters, huge but designed for optional bypass ratio and thrust. Each engine produces between 75,000 and 97,000 pounds of thrust, depending on the variant. They're remarkably quiet, meeting the strictest noise regulations with margin to spare, and they're reliable. Every system on the A350 was rethought. The electrical system generates more power than previous widebodies, supporting advanced functions while integrating traditional bleed air from engines for air conditioning and other systems. This balanced approach improves fuel efficiency and reduces maintenance, drawing lessons from competitors like the 787 while maintaining proven reliability. The A350 wasn't just built better, it was built smarter. June 14, 2013, Toulouse-Blagnac Airport. The first A350 XWB, wearing a special livery with carbon-fibre patterns exposed, rolled to the runway. MSN-1, manufacturer serial number 1. Inside, a crew of test pilots and flight engineers, prepared for what would either validate years of work or reveal problems that could delay the program indefinitely. Then, the Trent XWB engine spooled to full power. The A350 rotated smoothly and climbed into the French sky. The first flight lasted 4 hours and 5 minutes, taking the aircraft through basic handling tests, system checks, and performance validation at various speeds and altitudes. It was textbook perfect. No surprises, no issues, just a new aircraft doing exactly what it was designed to do. This stood in stark contrast to Boeing's 787 program, which had been plagued by various issues, including before it even flew for the first time. Airbus engineers had learned from Boeing's struggles, taking a more conservative approach to certain technologies while pushing boundaries in others. The first test flight campaign that followed was extensive. 5 test aircraft flew thousands of hours, validating everything from maximum altitude performance to extreme crosswind landings. They tested in hot and cold climates. They flew to remote airports and major hubs. They pushed systems to their limits and then pushed harder. One memorable test involved flying the A350 through artificial icing conditions, a dangerous and complex certification requirement. The aircraft performed flawlessly, demonstrating that its anti-ice systems and composite structure could handle the worst nature could throw at them. ETOP certification, extended twin operations, was critical. Airlines needed assurance that the A350 could safely fly routes over oceans and remote areas with only 2 engines. The testing proved that the aircraft could fly for over 370 minutes on a single engine, if necessary. far longer than required for any commercial route. In September 2014, the European Aviation Safety Agency granted type certification. The FAA followed in November. The A350 had gone from clean sheet design to certified aircraft in just 8 years, fast by modern standards, especially for something this complex. December 22, 2014, Qatar Airways took delivery of the first production A350-900 at a ceremony in Toulouse. Akbar Al-Bakr, Qatar's CEO at the time, known for his exacting standards and sharp criticism, smiled broadly. He had been involved in the A350's design from the beginning, pushing Airbus to be more ambitious. The handover represented more than just a commercial transaction. It was Airbus's redemption. While Boeing had struggled initially to develop the Dreamliner, Airbus had quietly built a masterpiece. Qatar Airways didn't just take delivery and park the A350 in a hangar, they put it to work immediately. The first commercial flight departed Doha on January 15, 2015. Passengers and media were invited to experience what Airbus had been promising for years. The reviews were unanimously positive. The cabin was quieter than any widebody they'd flown. The ride felt smoother. Even the air quality seemed better. But airlines don't buy aircraft based on passenger reviews. They buy based on economics, reliability, and operational performance. The A350 delivered on all three. Finnair became the first European operator, taking delivery in late 2015. They deployed A350s on routes to Asia and North America, replacing aging A340s. The fuel savings were immediate and substantial. Singapore Airlines, one of the world's most prestigious carriers, ordered A350s for both regional and ultra-long-haul operations. They configured their A350-900s with some of the most spacious business and first-class products in the industry. Cathay Pacific, LATAM, Vietnam Airways, Thai Airways, the orders kept coming from established legacy carriers and newer airlines alike. What surprised everyone was the dispatch reliability. Within months of entering service, the A350's reliability was remarkable. Pilots praised the cockpit. The fly-by-wire system made the aircraft easy to handle in all conditions. The automation was intuitive, the workload during long flights was manageable, and the visibility from that redesigned nose made approaches more comfortable. The composite structure required different techniques than metal aircraft, but Airbus had trained technicians well. Parts availability was good, support from Airbus was responsive. Even passengers noticed something different. On aviation forums and social media, frequent flyers started specifically booking A350 flights. They preferred the quieter cabin, the mood lighting, and the larger windows. The A350 was becoming a passenger favorite. For Airbus, this was validation of every decision made during the redesign. The clean sheet approach had worked, the investment in composites had paid off, the partnership with Rolls-Royce had produced exactly the engine the aircraft needed. The A350 was proving itself in the real world, where it mattered most. One aircraft is a product, a family of aircraft, that's a strategy. Airbus launched the A350 XWB with 3 variants, each targeting different market segments and directly challenging Boeing's dominance across the long-haul spectrum. The A350-900, the Goldilocks jet. This is the baseline model, and it's the one most airlines chose, seating between 300 and 350 passengers depending on configuration. The A350-900 offers range up to 8,500 nautical miles, enough to connect almost any 2 cities on Earth. It competes directly with the Boeing 787-9. The 900 became the workhorse of the A350 family, racking up the majority of the orders. Airlines use it on everything, from transatlantic routes to trans-Pacific marathons. It's efficient enough for medium-demand routes and capable enough for the longest hauls. The A350-1000, the 777 killer. Stretched by 7 meters compared to the 900, the A350-1000 was designed with one target in mind, the Boeing 777-300ER. The 777-300ER had ruled long-haul aviation for over a decade. It was big, reliable, and loved by airlines for its cargo capacity and passenger comfort, but it was thirsty. The A350-1000 did not match the 777-300ER's capacity, but it burned less fuel. It offered more range, around 9,000 nautical miles, which covered virtually every long-haul route airlines wanted to fly. British Airways ordered 18 A350-1000s, Qatar Airways ordered 42, Cathay Pacific ordered 20. These weren't airlines trying something new, these were 777 operators switching sides because the economics made sense. The 1000 entered service in 2018 with Qatar Airways, and it immediately proved itself. The range, the efficiency, the cabin, everything worked as promised. The A350-900 ULR, breaking records. Ultra long range, 3 letters that represent aviation's ultimate challenge, connecting distant cities with a single flight. Singapore Airlines wanted to relaunch non-stop service between Singapore and New York, a route they'd abandoned years earlier because the A340-500s they used were too expensive to operate profitably. Airbus responded with the A350-900 ULR, an enhanced version of the 900 with additional fuel tanks, modified landing gear, and a slightly reduced maximum takeoff weight to optimize range. The result? A range of 9,700 nautical miles. On October 11, 2018, Singapore Airlines flight SQ22 departed Singapore for Newark with a flight time of around 18 hours. This wasn't just a publicity stunt, it's been a regularly scheduled service since then, connecting 2 global cities without a stopover. The ULR also flies from Singapore to New York JFK and San Francisco. These routes simply wouldn't be economically viable with older aircraft technology. The A350F entering the cargo wars. For decades, Boeing owned the freighter market. The 747F, 777F, and 767F hauled cargo across the world with little competition. Airbus had tried with the A330-200F and A300-600F, as well as conversions, but neither achieved significant market penetration. Airbus was a passenger aircraft company. Boeing ruled cargo. Until 2021, when Airbus launched the A350F. Using the A350-1000 as a baseline, Airbus designed a purpose-built freighter with a reinforced floor structure, a large cargo door on the main deck, and optimizations for weight and capacity. The A350F can carry 111 tons of cargo, over 4,700 nautical miles, enough to connect major logistics hubs globally. More importantly, it burns around 40% less fuel than aging 747 freighters that many cargo operators still fly. Singapore Airlines ordered 7, Cathay Pacific bought 6, Etihad Airways added 7, CMA CGM, a French shipping giant, ordered 4. The A350F hasn't yet entered service as of now, but launch customer deliveries are expected to begin in 2027 after supply chain-related delays. The A350 became a family of purpose, not size for the sake of size, but aircraft designed to challenge Boeing across every segment of long-haul aviation. Not every member of the A350 family made it off the drawing board. When Airbus first launched the redesigned A350 XWB in 2006, it announced 3 variants: the 800, 900, and 1000. The A350-800 was supposed to be the smallest member, seating around 270 passengers and offering a range of approximately 8,500 nautical miles. It was meant to compete directly with the Boeing 787-8 and serve as a replacement for the aging A330-200 on longer, thinner routes. Initial interest seemed promising. Several airlines placed orders. The 800 looked like a solid complement to its larger siblings. But as development progressed, problems emerged. The 800 shared the same wing and engines as the 900, but with a shorter, lighter fuselage. In theory, this should have resulted in excellent range and efficiency. In practice, the aircraft became over-winged and over-engined for its size. The weight didn't scale down as much as expected, the economics started looking questionable, and worse, the performance difference between the 800 and 900 became marginal. Airlines began asking a simple question: Why buy an A350-800 when the 900 offers more capacity, similar range, and better per-seat economics? Operators evaporated. Hawaiian Airlines switched its orders to 900s. Aeroflot did the same. By 2014, few firm orders remained for the 800. Airbus faced a choice: invest engineering resources and production capacity into an aircraft few airlines wanted, or focus on the variants that were selling well. In July 2014, Airbus officially cancelled the A350-800. They redirected all remaining orders to the 900 or offered customers alternatives like the A330neo, which was just being developed and would fill the smaller widebody gap more efficiently. The cancellation was strategically smart, but also slightly embarrassing. Airbus had promoted a 3-aircraft family, and now 1/3 of it would not exist. But here's the thing, the A350-800's cancellation was a lesson in pragmatism. Airbus realized that sometimes the smartest aircraft is the one you never build. Resources that would have gone into certifying and producing the 800 went instead into perfecting the 900 and 1000, both of which became hugely successful. For over a decade, the Boeing 777 had been untouchable. Launched in the 1990s, the 777 family became the backbone of long-haul aviation. The 777-200ER connected continents. The 777-300ER moved masses across oceans with unmatched reliability. Airlines loved them. Passengers loved them. Boeing had created a twin-engine widebody that defined a generation. By the mid-2010s, over 1,400 777s had been delivered. Airbus's A340, designed to compete, had sold fewer than 1,400 before production ended. The battle wasn't even close. Then, the A350-1000 entered service. The competitive dynamics shifted almost immediately. Let's talk numbers. The A350-1000 offered a massive fuel burn advantage over the 777-300ER. Range was comparable. The 777-300ER can fly about 7,370 nautical miles. The A350-1000 stretches that to around 9,000 nautical miles. Both can handle any practical long-haul route, but the A350 does it more efficiently. Passenger comfort became a differentiator. The A350's quieter cabin, lower cabin altitude, and higher humidity made long-haul flights more tolerable. Pilots noticed that the A350's handling was lighter, more responsive, and required less physical input during long sectors. Then came the airline decisions. These weren't experimental purchases, these were fleet replacement programs. Airlines that had built their network around the 777 were now betting their future on the A350. Singapore Airlines, Emirates, Etihad, these airlines still operate 777s, but all have diversified with A350s. Even airlines historically loyal to Boeing were hedging their bets. Boeing saw this coming. They responded with the 777X, a stretched, more efficient evolution of the 777, with folding wingtips and new engines. The 777-9 was supposed to launch around 2020, maintaining Boeing's dominance in the large twin-engine segment. But delays hit, certification problems, design issues with the engines, quality control concerns across Boeing's production system. The 777X, as of now, still hasn't entered service. Meanwhile, Airbus kept delivering A350s month after month, quarter after quarter. The 777 replaced the 747. Now, the A350 was replacing the 777. The balance of power had shifted. For the first time in decades, Airbus wasn't chasing Boeing in the wide-body market. Boeing was chasing Airbus. The A350 didn't just win on specifications, it won because it aligned with how airlines wanted to operate in the 2010s and beyond. The Middle East, prestige, and rivalry. Qatar Airways became the launch customer for a reason. The A350 represented modernity, efficiency, and ambition, everything Qatar wanted to project as a global carrier. But there was also rivalry. Emirates, Qatar's regional competitor, had bet heavily on the A380 and 777. Qatar chose a different path, smaller, more efficient twins that could serve more destinations more frequently. The A350 allowed Qatar to open routes that wouldn't make sense with a 777 or A380. Secondary cities in Europe, Africa, and Asia became viable. The airline expanded its network not through bigger planes, but through smarter ones. Etihad followed a similar strategy. The Gulf carriers, once defined by their massive wide-body fleets, began appreciating flexibility over size. Lufthansa, Europe's largest airline group, ordered A350s, later assigned to Lufthansa, the airline, and Swiss. It needed to replace aging A340s that were becoming uneconomical. The A350 cut fuel costs dramatically and allowed Lufthansa to serve long-haul routes with better margins. Routes that required careful capacity management became profitable with the right aircraft. Finnair used A350s to position itself as the fastest connection between Europe and Asia. Its Helsinki hub sits geographically between the two continents. With A350 efficiency, it could offer competitive fares while maintaining profitability. Iberia, Air France, Virgin Atlantic, and British Airways all added A350s. These weren't orders of convenience, these were strategic decisions to modernize fleets and reduce operating costs. Asia Pacific, the long-haul laboratory. Asia became the A350's proving ground for ultra-long operations. Singapore Airline relaunched non-stop flights to the United States that were unprofitable a decade earlier. The A350-900 ULR made 18-hour flights economically viable. Cathay Pacific opted for A350-1000s on routes to North America and Europe. The fuel savings were immediate, and the passenger feedback was overwhelmingly positive. China Airlines, Vietnam Airlines, Thai Airways, and Philippine Airlines all integrated A350s. These carriers operate in intensely competitive markets where fuel efficiency and passenger experience matters enormously. Japan Airlines chose the A350 over the 787-10 for certain routes, appreciating the wider cabin and greater range flexibility. North American carriers have historically favored Boeing, but cracks appeared. Delta Airlines ordered 25 A350-900s, its first Airbus widebody purchase in years. Delta needed efficient aircraft to replace aging 777s, and the A350 offered the best economics. United Airlines, despite constantly pushing it back, still has its A350 orders. The common thread across all regions, airlines valued predictability and operating economics. The A350 delivered both. No drama, no surprises, just an aircraft that did what it promised, day after day, flight after flight. Strip away the marketing, the brand names, the liveries, and ask passengers what they remember about flying on an A350. They'll tell you it's quiet, remarkably, noticeably quiet. Conversations happen at normal volume even during cruise. Engine noise is a distant hum rather than a constant roar. The cabin feels insulated from the outside world in a way older aircraft don't achieve. This isn't accidental. The composite fuselage absorbs and dampens sound differently than aluminium. The acoustic insulation is more effective. The engines, while powerful, are designed for lower noise signatures. The result? A cabin that's quieter than previous generation twins. Lighting plays a subtle but important role. The A350 features LED mood lighting that can simulate sunrise, sunset, and various ambience throughout the flight. Airlines customize the lighting sequences, but the principle is the same. Use light to help passengers' circadian rhythms adjust to time zone changes. Does it work? Studies suggest yes. Passengers report feeling less jet-lagged after A350 flights compared to older aircraft, though multiple factors contribute to this. The cabin altitude is set lower. That means more oxygen in the cabin air, which reduces fatigue and headaches. The humidity is kept higher, combating the dry air that makes long flights uncomfortable. These aren't features you consciously notice during a flight, but your body notices. Windows are larger than on most widebodies, not as large as the 787s, but they are big enough to provide better views and more natural light. The window shades are conventional mechanical ones, which some passengers prefer over the 787's electronic dimming system. The cockpit is quiet too. Pilots can communicate easily without headsets during cruise. The head-up displays provide excellent situational awareness during approaches. The touchscreen interfaces, while not revolutionary, are responsive and logical. Long flights become less fatiguing for crews. The workload is manageable. The aircraft handles smoothly in turbulence. The systems are reliable. For passengers, that translates into a calmer flight experience, less stress, better sleep, the ability to step off a 12-hour flight and actually function. The A350 wasn't designed to impress, it was designed to disappear, leaving only the experience of flight itself. For decades, Boeing owned the freighter market. The A330-200F sold fewer than 40 units. The A300-600F had a decent run, but was ancient technology. Airbus was a passenger aircraft company. Boeing ruled cargo. Then, everything changed. In July 2021, Airbus officially launched the A350F, a purpose-built freighter based on the A350-1000 airframe. The specifications were impressive. The A350F can carry 111 tons of payload, over 4,700 nautical miles, enough to connect major logistic hubs like Hong Kong to North America or Europe to the Middle East without stops. The fuselage incorporates a reinforced floor structure to handle the concentrated loads of cargo pallets and containers. A large main deck cargo door allows loading of standard aviation containers and oversized freight. The A350F burns approximately 40% less fuel than 747-400 freighters, still operating in significant numbers. In an industry where fuel represents one of the largest operating costs, those numbers matter enormously. Airlines noticed immediately. By October 2025, Airbus had received 65 firm orders for the A350F. The first aircraft entered final assembly recently, and deliveries are scheduled to begin in 2027. Delayed a bit to supply chain challenges, but if successful, it will mark Airbus's long-awaited entry into a market Boeing has dominated for half a century. Environmental regulations are tightening globally, fuel costs remain volatile, airlines need more efficient freighters, and Airbus is positioned to provide them. The A350F represents Airbus's long-awaited credible entry into a market Boeing has dominated for half a century. The A350 didn't just reshape commercial aviation, it reshaped Airbus itself. Let's talk about production. The A350 is built across multiple European sites. Final assembly takes place in Toulouse, France, at a dedicated facility designed specifically for widebody production. Wings are manufactured in Broughton, Wales, massive composite structures that require precision engineering and specialized autoclaves for curing. Fuselage sections come from Airbus sites and suppliers. The center fuselage is built in Germany. Aft fuselage sections come from Spain. The nose section is manufactured in France. All those pieces travel across Europe via road, barge, and air to reach final assembly in Toulouse. The distributed production model keeps aerospace jobs spread across the continent. Britain, Germany, France, and Spain all benefit from A350 production. When Brexit threatened to disrupt supply chains, the A350 program became a test case for maintaining cross-border manufacturing relationships. The program also secured Airbus's financial future at a critical moment. The A380 program, while iconic, was a commercial disappointment. Development costs exceeded $30 billion. Sales never reached the volumes needed for profitability. By the time Airbus ended A380 production in 2021, it was clear the superjumbo had been a strategic mistake. The A350 offered redemption. Development costs, while substantial at around $12 to $15 billion, were also manageable. More importantly, the aircraft was selling. By September 2025, the A350 had accumulated over 1,400 orders. Production rates stabilized around 6 aircraft per month. The program has been profitable. This financial success mattered because it funded Airbus's next generation of programs. The A321XLR, which pushes single-aisle range to unprecedented levels, uses systems and technologies pioneered on the A350. The A330neo, while based on an older design, incorporated the next-generation engines and flight control improvements. Strategically, the A350 proved Airbus could execute complex, clean-sheet programs successfully. The 787 had been a cautionary tale of what happens when ambition outpaces execution. Airbus took notes. They were methodical. They tested extensively. They didn't rush to service. The result was an aircraft that worked from day one without drama. This built confidence among airline customers. It once again proved to the market that Airbus was a mature manufacturer, capable of delivering next-generation technology reliably. That reputation matters when airlines are making billion-dollar fleet decisions. The A350 didn't just save Airbus's widebody program, it secured the company's future as Boeing's equal, and, in some segments, Boeing's superior. To understand the A350's success, you have to understand what was happening across the Atlantic. Boeing's 787 Dreamliner was supposed to be revolutionary, and in many ways it was. The composite fuselage, the efficient engines, the passenger experience innovations, all of this was genuinely groundbreaking, but the execution? Catastrophic. The 787 program faced years of delays, production problems, supply chain nightmares. Then, shortly after entry into service, battery fires grounded the entire fleet for 3 months. Boeing's reputation for reliability took a serious hit. Airlines that had placed 787 orders waited years beyond original delivery dates. Others kept their 787 orders but added A350s as insurance. By the mid-2010s, Boeing had largely resolved the 787's technical issues. The aircraft was performing well in service, but the damage to Boeing's reputation lingered, and new problems kept emerging. Production quality issues became public. Manufacturing shortcuts were revealed in investigations. The 737 MAX crashes and subsequent grounding devastated Boeing's commercial division and raised questions about the company's safety culture. Throughout the late 2010s and early 2020s, Boeing stopped and resumed production multiple times due to production flaws. The 777X was supposed to restore confidence. Announced in 2013, the 777X promised to be Boeing's answer to the A350-1000, a stretched, more efficient 777 with composite wings featuring folding wingtips to fit within existing airport gates. New engines, modern systems, everything airlines wanted. First delivery was originally scheduled for 2020, then delays hit. The engines weren't ready. Structural problems emerged during testing. Certification requirements tightened after the MAX crashes. The timeline slipped into 2021, then 2023, then 2025, then 2026, potentially 2027. As of now, in late 2025, the 777X still hasn't entered service. Boeing has built dozens of aircraft that sit waiting for certification. Customers remain patient, but have grown frustrated. Airlines that historically bought only Boeing started diversifying. British Airways bought A350s, Singapore Airlines bought A350s, even Emirates, Boeing's biggest 777 customer, ordered A350s. For the first time in modern aviation history, the competitive dynamic had reversed. For decades, Airbus had been the challenger, the scrappy European consortium trying to keep pace with the American giant. Airbus aircraft were good, but Boeing aircraft were the gold standard. Now the A350 was the gold standard. Boeing was struggling to keep pace. Production quality problems continued to plague Boeing. Financial losses mounted. The company's commercial aircraft division, once the envy of the industry, looked vulnerable. This wasn't just about one aircraft program. This was about institutional momentum. Airbus had it. Boeing was losing it. The A350 succeeded not just because it was an excellent aircraft, though it certainly was, but because it arrived at exactly the moment when airlines were questioning their loyalty to Boeing and looking for alternatives. Airbus was ready with an answer. For the first time in decades, Airbus wasn't catching up. Boeing was. Let's take a breath here and talk about the remarkable things this aircraft has achieved. The longest flights. Singapore Airlines operates the 2 longest passenger flights in the world using A350-900 ULRs. Flight SQ23 from New York JFK to Singapore at 18 hours and 50 minutes, covering 9,537 miles. And Flight SQ21 from Newark to Singapore at 19 hours 10 minutes, covering 9,523 miles. These aren't occasional record attempts, these are regularly scheduled commercial services, operating multiple times per week. Passengers willingly book these flights because the A350 makes them tolerable in ways previous aircraft couldn't. Singapore to San Francisco, Doha to Auckland. These ultra-long routes connect cities that previously required stops in between. The A350 made non-stop service economically viable, but also the shortest. On the opposite end of the spectrum, A350s have operated some remarkably short flights. Demonstration flights in Japan have seen A350s fly Tokyo to Osaka, a route that takes barely an hour. Airlines sometimes reposition A350s on short hops between bases. The contrast is striking. An aircraft capable of flying 19 hours non-stop also works perfectly well on hour-long regional routes. That versatility is part of what makes the A350 family so appealing. Measured at cruise, the A350 cabin is quieter than many passenger cars at highway speeds. The difference is immediately noticeable to anyone who flies both the A350 and older widebodies regularly. The first Airbus with a carbon-fibre fuselage. The A350 marked a fundamental shift in Airbus's manufacturing philosophy. Previous Airbus widebodies used aluminium for the fuselage, with composite components in secondary structures. The A350 flipped that equation. The primary structure is composite. Metal is used selectively where needed. This represented an enormous technical and industrial challenge, requiring new manufacturing processes, new tooling, and new quality control methods. By September 2025, 650 A350s had been delivered to 38 airlines. The fleet has accumulated over 3.5 million flight hours and carried over 400 million passengers. Over 1,400 orders have been placed when you include all variants and the freighter version. This makes the A350 one of the most commercially successful widebody programs in aviation history. Several governments and private operators have ordered A350s as VIP transports. The aircraft's range and cabin flexibility make it ideal for head-of-state transport and ultra-long-range business aviation. Airlines created special schemes that became popular among aviation enthusiasts and photographers. The A350 is certified for operations over both poles. Airlines use this capability for routes where polar routing offers significant time and fuel savings, cutting hours off the flight time compared to equatorial routings. This requires special equipment and training, but the A350 handles extreme cold conditions without issues. The composite structure actually performs better in extreme cold than metal, which can become brittle. Airbus initially ramped up A350 production slowly, ensuring quality remained consistent. At peak, production reached 10 aircraft per month. The COVID-19 pandemic temporarily reduced rates, but they've since recovered to around 6 per month. Compare this to the 787, which Boeing pushed to higher production rates only to face quality control crisis. Airbus learned from Boeing's mistakes, prioritizing steady, sustainable production over maximum output. These records and facts paint a picture of an aircraft that's not just technically excellent, but genuinely versatile and reliable. The A350 works across an incredible range of missions, from record-breaking ultra-long haul to routine regional services. That's the mark of a truly great aircraft design. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?